everyone. Thank you for joining the first webinar in the American Concrete Institute webinar series led by Josie Zamachis, the Senior Engineer at ACI. The topic today is low compressive test results, what they mean, and the next steps. The webinar series will continue tomorrow and Wednesday at the same time with other leading industry experts, and you can access all three of these webinars. All the webinars will be recorded and you will receive the recording and the presentation within the next week. If you have any questions, please direct them to the Q&A box at the bottom of your screens and we will try to answer as many as we can towards the end of the presentation. I will now pass you over to Josie. Hi, Josie.
Hello, Ev. Thank you for having me. Thank you for having the conference, and thank you for having the ACI series. As Eleni mentioned, my name is Josie. I work at ACI. I have been working for 10 years. I got my degree initially from the university in Poland, Technical University of Gdańsk, and then got my doctorate at Virginia Tech here in the United States. I have worked as a structural engineer in brick design, in condition assessment, corrosion condition assessment. Did a lot of testing while I was at construction technology laboratories in Chicago area, and now I'm with ACI. So today's talk is about the low strength concrete and low strength test results. But what I want to say up front is that the whole presentation is ACI centric. So it's based on these two documents that you see on the screen. ACI 318, which is ACI building code, and ACI 301, which is specification for structural concrete. In other words, it's very likely that other codes, Euro codes, British codes, and local codes or specifications may have different requirements. So again, the emphasis is this is based on ACI codes and specifications. And I'm not trying to say that the same acceptance criteria for strength are with other codes. The learning objective for today is to understand what the strength test is and what it is not, to learn the methods of sampling concrete for those tests, including handling and curing, transportation to the lab and everything like that. Then we'll try to find out what those acceptance criteria are and understand them a little bit better, how to interpret strength tests not meeting those acceptance requirements. And what comes with this is that some of that concrete that was placed represented by those tests will be treated as non-compliant, so how to investigate that. And finally, how to address those low strength concrete issues in production, meaning by the ready-mix suppliers. Rather than kind of outline, we'll be looking at trying to answer those questions. What is that strength and why is this needed? How often do we conduct those tests? The acceptance criteria, as I mentioned already, investigation of those strength tests not meeting acceptance requirements. And let's say you go through all that exercise and you still identify that your concrete is non-compliant when it comes to strength. So we'll talk about the next steps as instructed by the code, ACI 318 or ACI 301 specifications. We'll also try to answer the question who pays for testing, even though it's not definite because all specifications vary, but we'll look at this and finalize by looking at options for the concrete producer, what they can do to make things easier for them. The last slide will be additional resources and also the resources that I have used to prepare that presentation. So what is a strength test and kind of to some degree why it's needed? We go to the ACI terminology, ACI CT18. You can download it from our website for free if you want it. And it says that specified concrete compressive strength is the specified resistance of a concrete specimen to axial compressive loading used in design calculations. So structural engineer uses in design calculations and as the basis for acceptance of concrete used in the work. So it's kind of dual purpose. So this is not only needed for design, but also needed for acceptance. And throughout this presentation, I will use the term specified concrete compressive strength on equal footing as specified strength. So when I say specified strength, this is what I mean. I mean specified concrete compressive strength. And at the same token, when I say strength, I mean compressive strength. Obviously, there are different strengths, tensile strength and shear strength and bond strength, you name it. But every time I mention strength, I mean compressive strength, at least for the purpose of that presentation. So why do we need it? ACI 318 explicitly says evaluation of hardened concrete shall be based on strength tests. So this is why it's needed. It's for design purposes, acceptance criteria, and also for evaluation purposes. So what is the strength test? And this is very important. The definition in ACI 3 is a long one, but we have to go through this to understand it. So let's kind of divide it into little chunks. So the very important thing is that the strength test is the average of the compressive strength of at least 2 cylinders that are 150 by 300 millimeters, or at least 3 cylinders 100 by 200. So again, the strength test in the definition of ACI 318 and ACI 301 is not a 1 cylinder break or 1 cylinder strength. It's the average of either 2 cylinders or 3, depending on the cylinder size. So that's the first very important thing. And if you are to remember one thing, I would probably say remember that one. Then it says it must be made from the same sample of concrete in accordance with ASTM standards. And the standards that are mentioned is C172 and C31. And then it says it should be tested in accordance with ASTM C39. Also gives that should be tested at 28 days or at a test designated for the specified strength. So that specified strength may be 56, maybe 90 days, maybe 7 days. Kind of depends on the job that you are working on. So we'll look at those specifications and some of the requirements that are there in more detail. Before doing that, let's define those things. What is not a strength test? So when you do the test on cylinders that are not field cured, or cylinders that are made from the laboratory trial batches, they are not considered a strength test. Again, you'll get strength values, strength breaks, but they are not considered in the language of ACI 318 or 301 a strength test. So from that definition, the concrete has to be taken, the sample of concrete taken in accordance with ASTM C172, which is standard practice for sampling freshly mixed concrete. And when you go through the standard, it tells you that the composite sample must be made, and there are some requirements regarding minimum volume of concrete to be sampled, and also talking about number of portions and portions of the batch of the concrete to sample. I'm not going to say exactly what they are, I'll just refer you to that standard, but there are different requirements depending on the type of mixer. So the standard talks about stationary mixers, it talks about paving mixers, revolving drum track mixers and agitators, open top track mixers, continuous mixers. So depending on the mixer, it will tell you that you may need to take just one portion for sampling, or maybe you need to take 2 or more portions, and it will tell you whether you are allowed to take it from the beginning of the batch, end of the batch, or middle of the batch. And most of the time you'll find that the first 10% or last 10% of the concrete that is as delivered in the concrete, let's say a ready mix truck, you cannot take it for sampling and preparing specimens for strength test. But again, go there to C172 to get the details. Here's an example, a picture of a concrete diverted from the job site to a wheelbarrow to create the composite sample. So the next standard mentioned in the definition is ASTM C31, which is standard practice for making and curing concrete test specimens in the field. And what you find there is that you will find all the information regarding testing requirements, specifically what cylinder size to use. It will talk about sampling concrete and will refer back to ASTM C172 that we have just discussed. And as you can see, the samples being prepared, as you see in the pictures, are made from that composite sample that is in the wheelbarrow. It will talk, I'm talking C31. So C31 will talk about molding specimens, casting them, consolidation, what type of method it is, whether vibration or rotting. It will talk about initial and final curing. And final will also talk about transportation to the laboratory. So remember, the first thing that C31 talks is about the specimen size. So the important part is what diameter of concrete to use, not concrete, of the cylinder mold. So the first thing is that the cylinder size, the diameter of the cylinder has to be at least 3 times the nominal maximum aggregate size. And depending on your nominal maximum aggregate size in the concrete, you may use either smaller cylinders, 100 by 200 or 150 by 300. So it's a decision made typically by a structural engineer or person preparing specifications for the job. And if it is larger nominal aggregate size, you use 150 by 300. And then you may ask, okay, so what happens if I have, 75 millimeter size aggregate? Well, in that case, the specification requires you to wet sieve through a 50 millimeter sieve when that nominal maximum aggregate size exceeds 50 millimeters. When it comes to consolidation, the method of consolidation depends on the slump of concrete. For less than 25 millimeters, it's vibration only. For greater than 25 and equal to 25, it's either vibration or rotting. It's selected by the technician doing preparing the specimens. So when it comes to consolidation by vibration, the requirement is to place concrete into cylinder molds in 2 layers and vibrate it by 1 insertion for smaller cylinders and 2 vibration per layer for the larger specimens. And when it comes to rotting, there are 2 layers for smaller cylinder and 3 layers for larger cylinders. There's a difference in rod diameter that you need to have, and also the number of rods per layer is the same regardless of the specimen size that you use. Here's an example of a technician preparing specimens for strength test, consolidating concrete by rotting. The next thing that ASTM C31 discusses is the standard practice for making and curing concrete test specimens is the initial curing. The timing is defined for initial curing as the initial 48 hours after molding. There's a requirement, temperature requirement and moisture requirement depending on the strength of specified strength of concrete. And the important part is that moisture must be preserved on all specimens at all times. And there are little tight requirements for concrete at higher strength, specified strength at 40 MPa. The next thing is the transportation to the laboratory. That can happen at least 8 hours after after final set of concrete, and the transportation itself shouldn't exceed 4 hours. So we're still talking about the period of time within the initial 48 hours after molding. There's no requirement regarding temperature except protection from freezing, which in case of Dubai and Middle East doesn't really apply. So the temperature requirement can exceed the 26, 27 degrees Celsius that was required for initial curing, but the moisture must be protected from evaporation. Final curing is when the specimens are stored in the laboratory condition. The very tight temperature requirements, 21 to 25 degrees Celsius. And the specimens are typically kept in the moist room or in water storage tanks. Just before the testing, the specimens can be taken out from the moist room or the water storage, but not more than 3 hours. There's a little bit wider temperature range that can be maintained. The specimens can be maintained at, and the moisture must be preserved until the testing itself. So now that we know how to prepare them, very few words about factors affecting strength. We are not discussing the whole topic. It's just few of those things, because many people ask, do I go with the smaller cylinder size? Do I go with the bigger one? It's really not that important, but I want to mention that smaller cylinder size yield higher strength. So typically, when you compare the two, you may expect about 4% higher strength with 100 by 200 cylinders versus 150 by 300 if they are made from the same batch of concrete. When you moist cure the specimens, you can expect higher long-term strength in the specimens that are moist cured all the time. And the same thing when it comes to temperature, the lower temperature will yield higher strength at later ages. Going back, I put some sources at the bottom of the slide. You can read a little bit more and find out more when you go through those sources, either article by price or EB001 book from Portland Cement Association. So the question now is, okay, so we know about what the strength test is. We know how to make the specimens, how to cure them. Who can conduct the test? The first thing is that the acceptance testing can be done by the testing agency that is compliant with ASTM-C 1077. Go to that standard, see what it is about. But this is the requirement that is within ACI 318. The specimen preparation itself for the strength tests has to be made by certified field testing technicians or equivalent, but certified field testing technicians, and laboratory testing by certified laboratory technicians. ACI provides those certifications, and ACI local chapters and other organizations can help you out with that certification. I believe in the region is ACTS that provides the certification. You can find a little bit more information on ACI website under certification, and there are also learning resources through ACI University that provide information how to prepare for those tests. So, okay, we talked about everything. We talked about the specimen preparation, curing, and everything. The testing itself is done in accordance with ASTM C39, but I think the easiest way to understand the whole concept is going through the example. So let's say we have conducted some of the strength testing in accordance with ASTM C39, and we did it on 100 by 200 cylinders. And here are our test results. We have 3 cylinders, we have 3 strength tests, and this is what we refer to. These are compressive strengths or cylinder strengths. Some people even call it cylinder breaks. So this is what they are. These are not strength tests. The average of those cylinder strengths is the strength test. So this is what it is. Each cylinder is just cylinder strength or cylinder break. It's not a strength test. The strength test, kind of repeating myself often and often, but I just want you to remember that the strength test is the average of 3 cylinders, 100 by 200, or 2 cylinders, 150 by 300. Okay, so strength test is the average of several cylinder breaks. Okay, now how often do we conduct those tests? And we find it in in ACI 318, chapter 26. Let's look at it in detail. So it says that the strength test is done at least once a day, at least once for each 110 cubic meters of concrete, and at least once for each 460 meters of slabs or walls. In other words, if you construct a slab or a wall, and then you are asking, okay, do I go by the volume of concrete, or do I go by the size, or by this area? You have to look at both and see which yields a more frequent testing. That's what you do. But kind of the rule of thumb is that if your thickness is less than 240 millimeters, you go by the area. If it is greater than 240 millimeters, you go by the volume. You can do the calculation yourself and you will find it's 239 and something. Okay, the next thing in that provision is that you must have a minimum 5 tests, 5 samples for the test. In other words, if you do the smaller cylinders, you would do 3 cylinders for 1 test, but you must have those 5 strength tests. So you must have it from 5 randomly selected batches. And if you have less than 5 batches, you need to do it from each batch. And then somebody, okay, I have particular concrete mixture. I only use it at, I don't know, 20 cubic meters. Do I still do the test? If there is evidence of satisfactory strength from the previous jobs, and it's provided to the building official, and the building official approves that, then you don't have to do that. Again, you must have the approval of the building official to not to conduct the strength test. Okay, and that brings us to acceptance criteria. And that is, again, in chapter 26. And we find that each strength test at least for the concrete with the specified strength of 35 MPa or less, has to be equal to or greater than the specified strength less than 3.5 MPa. And if it is for concrete with specified strength greater than 35 MPa, it has to be greater than or equal to 90% of that specified strength. So this is the acceptance strength level for each strength test conducted on concrete in question. There's another requirement regarding 3 consecutive strength tests, and it looks at the average of those, and they have to be equal to or greater than the specified compressive strength. ACI 318 and ACI 301 have the same requirements. Let's look at an example. We have a placement requirement, 80 cubic meters of concrete with the specified strength of 28 MPa. And for argument's sake, let's say that each of those can bring 8 cubic meters of concrete. So we will need 10 ready-mix trucks. And we treat each truck as a batch of concrete. So the random sampling that we conduct, random table, random number generated from a calculator, whatever that is, the random sampling that comes up, let's say it's trucks or batches number 2, 3, 5, 7, and 10. You collect the samples, you do the testing, and here are the strength tests. Again, the numbers that you see are the average of those 3 cylinders. So here are the numbers, and we have those 5 strength test results. And then, as you remember, for acceptance criteria, we also have to look at the average of consecutive 3 tests. So what is meant in that is that you are looking at the first 3 tests and you take the average, then you take a look at the average of the next 3 and the next 3. So this is what is meant by the average of 3 consecutive tests. Okay, so we have those values of each individual strength test. We have those values of average 3 consecutive tests. Now we have to compare them to acceptance criteria that we've discussed before. Okay, so this is what we have. And what you see on the slide, I have those acceptance criteria and this 0.9 F'(CI) crossed out because it's applicable to strength above 35 MPa specified strength. And in our example, our specified strength is 28 MPa. So when we look at this 28 minus 3.5, it yields 24 MPa. So we can compare the values for our strength tests from individual trucks, and we see that one of those, truck number 3, is less than 24.5, meaning it's non-compliant. Now the question is, how about 27.2? It's less than 28, which is specified strength. According to ACI 318 and 301, it's not a problem. It's allowed to have a strength test being below the specified strength. But since it's more than 24.5, it's not a problem. However, the average of 3 consecutive strength tests has to be greater than or equal to 28. And what we see, is that 2 of those consecutive strength tests are non-compliant. So the reason for that example is that now we can look at what do we do regarding that non-compliant concrete. Before doing that, I just want to mention another publication that is free of charge. You can download it from the ACI website, E702.3, which is Designing Concrete Structures, and talks about those acceptance criteria and acceptance of compressive strength in a little bit more detail. It has like 15 examples with individual cylinder breaks and everything. However, it's not in SI system of units, in US units, but being engineers, I think you will have no problem converting from English units or US units to metric SI. But again, have a look at this if you'd like to see it in more detail. Okay, so we go back to our example, and what does it really mean? So here are some of the steps that are needed to be done. So we have those 2 requirements in the first column, which kind of repeating, each strength test has to be greater than the value or that limit allowed for acceptance, which is specified strength less than 3.5 MPa for concrete with specified strength up to 35 MPa and 0.9 F'(C) for concrete with 35 MPa greater, and also for the requirement of average of any 3 consecutive strength tests have to be equal to or greater than the specified strength. The required action by ACI 318 says steps shall be taken to increase subsequent strength tests in both cases. What does it really mean? It means that the concrete supplier has to maybe increase cementitious material content, maybe reduce water content, using water reducing admixtures to improve dispersion of cementitious materials to get better strength at the required test age, making other changes to mixture proportions that they find would be beneficial to increase strength. Reducing delivery time may help. Looking at closer control at air content, which probably not a big deal in the Middle East, but even entrapped air can contribute to reduced strength. So maybe that can help, especially with the specimen preparation, which is the last point, having strict compliance with C172, C31, but also reducing concrete temperature during specimen curing will definitely help with increasing the strength at the test age. And it's important to have all these things in mind. But again, hopefully you are not there. You don't have to do those things. There are several publications by ACI that talk about how to deal with those low strengths, how to address them. On the right-hand side, you see a report on chemical admixtures, ACI 212.3R. It talks about every single one, chemical admixtures and how it affects strength. The document on the left, ACI 211.8R, talks about different aspects, and one of those happening in the mixtures is low-strength concrete, and they look at different things like happening in the mixture, you know, changing in cementitious or other raw materials production, seasonal changes, what happens if you add water beyond originally specified, improper sampling, and so on, and provide some possible adjustments that is provided in the table. So again, refer to 211.8R for additional details. So going back to those requirements, so let's say you all take all the steps and still you have the issues. But another thing is that it's not only those steps to take to increase subsequent strength test, but if you have non-compliance when it comes to the individual strength test, you must also investigate those strength tests. And what does it mean? Before we look at those investigation itself, we must emphasize that this is applicable for new construction only. So once the building or construction is finished and let's say certificate of occupancy for the building is released, it's no longer ACI 318, it's something else. So it's investigating of those strengths is only when you are still under construction, the whole construction job site, right? So that's the caveat of ACI 318. But what does it mean to investigate those strength tests? And another provision in ACI 318, very long, so let's look at it in detail. But the beginning of it says, if any strength test or standard Q cylinders falls below the specified strength by more than the limit allowed for acceptance, and again, the limit allowed for acceptance, this is what we talked about, depends on the specified compressive strength. So this is what you see on the screen. Or if the test of field cured cylinders indicate deficiencies in protection and curing, and now you say, hey, there's nothing about field cured cylinders, they are not part of the strength test, and that's true. But building officials may require field cured cylinders or licensed design professional, and LDP is meant as the engineer of record for some of you who use that term. But they may specify field cured cylinders for other reasons than the strength test. So in other words, if you have them available, you can look at them. And then it says steps shall be taken to ensure that structural adequacy of the structure is not jeopardized. And what does it mean, those steps? What kind of steps are we looking at? So that means looking at structural analysis. The structural engineer looks at, says, hey, for that concrete strength, specified strength of, let's say, 35 MPa, that particular member that the concrete is represented by those strength tests, maybe it doesn't require 35, maybe it requires 25 MPa, so maybe it's okay to leave it as is. So that's what is meant by structural analysis, looking in detail which member is affected. You are looking at those field cured cylinders that we mentioned, if you have them, of course. And then the other option is conducting in-place tests, and that refers to ACI 228.1R, which is this document that you see on the screen. And there are many test methods mentioned that you can try to estimate the in-place strength. ACI 318 and also ACI 301 mention those four that you see on the screen: penetration resistance, pull-out test, maturity, and cast-in-place cylinders. The important part is that in either case, whatever you choose, sufficient correlation data is required. And also permission has to be granted before using any of those test methods. So again, correlation is key. Please look into ACI 228-1R for details. Okay, so let's say we have those low strengths. We looked at the field cured cylinders. Steps shall be taken. So we looked at those strength tests, structural analysis, in place strength. But low strength is confirmed. What do we do next? Then the code says core testing is the next step. So before we go there, let's look at the differences between 318 and 301. 318 says investigate strength, and once that investigation is not conclusive, then is the core testing. ACI 301 goes directly to core testing. Okay, so we have the core testing. How do we do that? It has to be in compliance with ASTM C42. Cores have to be drilled from the area in question. In other words, once you have a low strength test, you look at the construction records and see which concrete that was, which concrete that represented, find out where it was placed. So that's the concrete to be drilled at. No, it's the concrete, the area in question. And the minimum number of cores is 3 for each failed test. So if you have 2 failed tests, you must have at least 6 cores. You can do more, but not less. The acceptance criteria are that each core strength has to be equal to or greater than 75% of specified strength, and the average of those 3 cores have to be equal to or greater than 85% of the specified strength. And then probably you will have questions, okay, how about the diameter of the core, how about the moisture conditioning and everything else? How does it affect? The ASTM C42 is very specific. If you want to deviate from the ASTM C42 requirements, please go to ACI 214-4R, Guide for Obtaining Cores and Interpreting Compressive Strength Results. And you will have a lot of good information in that document. Okay, so let's recap everything what we talked. So standard cured cylinders, let's say it failed, structural adequacy has been checked, it's still in doubt. You look at field cured cylinders, they failed. If you have them, or you don't have them maybe. You looked at in-place strength evaluation, you still have low strength values. You do the core testing and you still have some problems. And in that case, ACI is very explicit. It refers you to chapter 27, which is the load testing. And even though it's not part of the presentation that I have for you, this is a very expensive proposition, and I hope none of you is in that situation. So the question is about the payment, because once you are there, it's oftentimes who pays for the additional testing. ACI 318 is silent, there's nothing about that. ACI 301, however, if it is specified, there is some language in 163 and 164, and it says that the concrete strength test, which is part of the QA, quality assurance, is paid by the owner. Additional testing of materials or concrete because of failure to meet specification requirements is on the contractor. And when it comes to test to verify strength of concrete in structure is on the contractor. However, it also says that only if subsequent testing confirms concrete does not meet those acceptance criteria. So again, this is about payment, but again, every project is different. And from my experience, I say that this is not really binding because the specs for every single jobs are a little bit different. And oftentimes when you have a reference to other specifications like ACI 301 or ACI, different specifications, hot concrete, cold concrete, curing and so on. Typically there is a language saying that in case of conflict, the provisions of such and such specifications govern. But again, if you need some of that language, this is where you find it. Now we get to concrete producer or ready-mix supplier. What can they do to reduce likelihood of the low strength test results? So we'll look at something called required average strength, and we'll also look at some of the statistics. So we go back to our ACI concrete terminology, and we find that the required average strength is the average strength of concrete used in mixture proportioning, okay? Mixture proportioning, to ensure a high likelihood that the concrete will meet specified strength accepted criteria. Okay. So the goal here is to have some kind of average strength of concrete when you prepare the mixture, so you have high likelihood that it will be accepted based on the testing and acceptance criteria that we have just covered. Okay, so when you look at normal distribution of the strengths of the test that you do, and again, this is an example. Let's say your mean or the average value of the strength test that you conduct is 28 MPa. And let's say the standard deviation of those is 3 MPa. I'm not going to define what the mean is, standard deviation is. I make that assumption that you know it. If you don't, please look into your statistical textbook. So for that thing, this is the typical normal distribution curve that you would expect. And let's say that 28 is our specified strength. So if this is our specified strength, 28 MPa, and we know that our acceptance criteria, the way they are, which is F prime C minus 3.5 MPa, it means that our lowest acceptance value for the strength test is 24.5 MPa. So then we have that area on the left of 24.5 representing percentage of tests that can be expected to fail that acceptance requirement, which means that in this particular case, 13% of the tests would be less than 24.5. So the question is it acceptable? And probably many of you would say, hey, 30% is a fairly high number. I don't want 30% of my tests to fail and then have problem down the road. So before we go and say what the area should be, the next curve that you look at is the cumulative normal distribution function. It's the same distribution, is just represented as a cumulative normal distribution. So for our F prime C, you see that F 50%, meaning that 50% of the test will be less than F prime C. And for 24.5, it's 13%. But what we want is something different. We want some lower value than 30%. But what is that lower value? That thing is kind of defined in ACI 214R, which is Guide to Evaluation of Strength Test Results of Concrete. And in the document, you will find that the required average strength, represented by FCR prime, should be established where the failure to meet the specified strength is anticipated at no more than 1 in 100 or 1%. So going back to our curve, it means we want to be at 1%, not at 13% from our example. It means we need to shift that curve so that our required average strength is resulting in that curve giving 1% at 24.5. So now the question is, how much do we shift that curve to obtain the required average strength? And that depends whether you have some data from that concrete mixture that you are considering or you don't. If you don't have any data, then you use that table, and let's say you have specified strength of concrete is 30, it means that your required average strength has to be 38.3. In other words, you are making concrete so that strength is 38.3. The average strength of all the tests has to be a minimum of 38.3, and that will, from the statistical viewpoint, will guarantee you that you will not get more than 1% failure. Okay, for 50 MPa strength, specified strength, you would need required average strength of 60, because 1.1 times 50 is 55, plus 5 is 60. Okay, so this is when the strength data is not available. If you have strength data available, then it depends on the specified strength and also on the number of tests that you already have the data. So let's look at an example. Before going to those formulas that you see in those, let's look at an example. Let's say we have specified strength concrete of 30 MPa. The N is 15, which means that we already have 15 data points, 15 strength tests done before. Based on that data, we have standard deviation S sub S of 4 MPa. So we take from the second table for 15 tests, the value of K factor is 116. We use those two formulas that you see in the first table, and we have to calculate them both. And once you have them both, you compare and you take the higher value. So this is your required average strength that is to be used in mixture proportioning design. Okay, so this is your target, 37.3, and that will guarantee that your specified strength 30 MPa concrete will not have a failure rate greater than 1%. Okay, statistically. Another example, if you have 50 MPa concrete, again, number of tests done before is 15. Again, depending on that number, maybe you have 20, then you would have a K factor of 108. But in that example, I have 15. You take the first formula, you calculate the required average strength, you take the second formula, and in that case is the formula that yields higher average strength, required average strength. This is what you use in mixture proportioning. Okay, if you want to study more, you look more, look at MNL2, Manual of Concrete Inspection. They have a full example there. And that brings us to control charts. This is something that concrete producers often do. Then when you look at the individual strength test, you kind of graph your specified strength. You look at your required average strength and you plot it so you can see where you are and how things affect your strength values, maybe weather patterns, maybe timing, how long it takes to the laboratory, all these things. It's really up to ingenuity of the people in charge at the ready-mix plant. But these charts are very useful because once you make a mistake, probably you will never repeat it. So that's why the control charts are very useful. The second one is looking at average of 5 tests, just to see the trends, how they go, and also range of 2 cylinders. Again, these are examples, but please look at those publications, the ACI 214R or Manual of Concrete Inspection that I have already mentioned, where control charts are discussed in more detail and examples are given there as well. Here are the materials documents that I used in preparation of that presentation, and they have significantly more information than what I have presented. So have a look at those. For those of you who are ACI members, all documents with the letter R, like 228, 1R, 214R, and so on, the letter R indicates it's either a guide or a report. They are free download for you. So just log into into ACI website and you can get them once you log in. With that, thank you very much. I'll be happy to answer any questions you may have. And if you have some question about ACI, we have our local representative, Ahmed Mana, who's the director of Middle East North Africa region. Here's the email. He is in Dubai, so make a note of this. And I also want to mention that there are 2 more presentations. One is tomorrow, one after tomorrow. So please consider joining Big 5 conference and listening to Nizar and Salah tomorrow and afternoon tomorrow. Thank you very much. And if you have any questions, I'll be happy to answer that. I will go back to Ahmed Mana, so you can note his name and contact, and I'm open to any questions. Thank you very much.
Thank you, Josie. We have quite a few questions, so we'll just spend a few minutes. I'll ask you
Sure.
some. Is the rebound hammer test acceptable as a criteria for accepting or rejecting concrete?
Well, like everything in life, it depends on the contract document you have written and the building official and the engineer of record or LDP, licensed design professional. Rebound hammer is, for those of you who don't know, it's a non-destructive test, and it's kind of like a plunger, and you hit the surface of the concrete and gives you rebound number, and you compare with some values and gives you estimate of the strength. But based at least on my experience, it varies depend on the concrete aggregate that you have. I think it's a good test method for comparison purposes, one area versus the other. I would not use personally for acceptance criteria, but again, this is my personal opinion, not ACI statement. It's definitely a good test method, very easy to use and very quick for comparison purposes. For acceptance criteria, well, if you really have good correlation and you convince the building official and LDP, well, it's their decision, of course. But it's a very good question. Thank you very much.
Another one, what is the difference in strength between a sample tested in the lab and actual pile concrete on site? Which one has got more strength?
Oh, that's a very good question. Well, if you have to test them and then tell me. But in reality, you can have strength tests done in the field with a higher strength versus laboratory and vice versa. As I mentioned, there are many factors influencing strength. Temperature is one, and moisture condition is second. And the timing of the test is of importance as well. In other words, if you have drier sample, because let's go back. Laboratory sample is one that is moist and is at the laboratory temperature, which is room temperature, let's say, I don't remember, 24 degrees Celsius, right? 26. In the Middle East, you likely have temperature much higher than 21, 26. So the one in the field will have higher temperature. It will also likely, if it is in the field, will not be kept in water, or maybe kept in water, but the temperature will be higher. And let's say it is drier. At lower ages, it will be higher strength. At later ages, the strength will be lower. So if you are looking at long-term durability thing, you want to limit the temperature to as low as possible. In the United States, I would say not as low as possible because you are getting into freezing issue. In the Middle East, you don't have that problem. But that's what you would see. And how much different that would be, the easiest thing is to test it. If somebody tells you, hey, after 14 days, you will get 5% more on this versus that one, I would say, hey, that worked for that person, but for you, it may be different. So every situation is different. But again, drier concrete and higher temperature concrete will yield higher strength early. Long term, it's vice versa. Thank you for the question.
Another one is, what is the benefit of using a cylindrical mold instead of a tube mold?
Oh, I think it's economical decision. Middle East and Europe, I think, use the cubes. Labor is cheaper. so you can reuse the molds. In the States, labor is expensive, so cleaning the molds takes time. Cylindrical molds provide you with consistency. There's also an issue of concrete placement. When you place in the cube, you put it in, I don't exactly know the specifics, but once you place the concrete and you consolidate it, the testing is not the same direction as you placed it. You rotate the cube and then you test it. The cylinder is the same way as you consolidate it. So that's one. The stress distribution is somewhat different, but we are going into details of stress distribution, and I don't want to go there because it will take a lot of time. And I'm not an expert, so I wouldn't go there. And if I'm not mistaken, I may be wrong, but if I'm not mistaken, I think with the cylinders, you get a little bit better consistency. In other words, the standard deviation would be a little bit better with cylinders, supposedly. There is one of the ACI committees, I think ACI 214, that is looking into releasing a document like a tech note, kind of mentioning about the cylinder versus cube strength, but I wouldn't say one is better than the other. It's just ACI documents refer to cylinders because the testing of cylinders is standardized in ASTM, and ASTM are referenced as the standard test methods in ACI documents. So I would say that's the main reason why cylinders are there. If ASTM came up with cubes, possibly ACI would. Again, it's not ACI as staff, it's ACI technical committee members who are volunteers, professors, practitioners, engineers, people like you. They make decision whether it's reference or not. But ASTM doesn't have a standard on cube tests.
How do you do core test for slabs of 120 millimeter thickness?
120 millimeter. Well, it depends. If you can core all the way through, right? So one way is to core all the way through, and you have the core of the full slab thickness. If the slab is on grout, it's no problem. You just pick up your core. If the slab is suspended slab, there are ways of protecting it from below. If you have no access to get to below, let's say on a bridge deck, sometimes what is done is you drill a pilot hole or 2 pilot holes and somehow make a protection from underneath through some kind of wires or some. It's really engineers' ingenuity. You come with plywood or something, but you just core all the way through. And if you do not want to core all the way through, depending on your diameter, remember ASTM C42 requires you to have the length to diameter ratio of at least 1. So if you have 120 diameter slab and you have 100 millimeter or less core diameter, the drill diameter bit, you can drill only 100 millimeter deep and break the core, and then you should be fine.
Does ACI provide any guidance on correlating cube samples to ASTM procedure?
Not at this moment, and I don't think there will be a correlation per se. As I mentioned, ACI 214, I think ACI 214 is looking into developing a tech note, which is a very short report on cube versus cylinder strength. And I don't know when it will be released. I know the committee is very close to balloting it, meaning making decision on finalizing the document for release. But you would have to check with ACI 214.
Okay, I think we have maybe time for one more.
Sure.
What is the best approach for concrete strength testing for projects in remote areas far away from test labs?
Oh, that is a fantastic question. I don't think there is a procedure per se. Remember though that each strength test or strength testing is conducted typically at 28 days. Can be more, can be less. So it takes 28 days. Again, I'm talking about ACI documents, which refer to ASTM. And as you remember, the initial 48 hours is the initial curing. That's when you cast and mold your specimens and eventually protect them from moisture loss. And then you transport to laboratory, and 4-hour time is the time to transport to laboratory. But even though the cost may be high, possibly you can get some samples to laboratory that quickly. And if it is not feasible for extended time, for extended usage or procedure that way, maybe some arrangement can be made that samples are stored on site in, let's say, some kind of water tanks. And I don't know whether air conditioning would be possible to have or not, but kind of in water, definitely moisture is more critical than the temperature, in my opinion, but temperature is important too. And then somehow make correlation to laboratory cured specimens, and then that would give indication of what kind of strength test you can expect, whether they would be higher in the field or lower in the field. So I think some kind of correlation would have to be made to test specimens as cured in the laboratory. That would be my take on it. Again, all of this has to be discussed with a licensed design professional who typically represents the owner.
Okay, thank you. I think that's all the time we have. I know we've received a lot of questions, so I guess feel free to contact Mr. Ahmed if you haven't gotten your question answered. Thank you so much, Josie, for your time and for presenting today. Just let the attendees know, we will send the presentation and a recording of this webinar to you all within the next week. So just keep an eye on your inboxes. And the ACI webinar series will continue tomorrow. You will receive an email to log into the next webinar at 3 p.m. UAE time tomorrow. Thank you so much, Josie.
Thank you very much. Thank you very much for having me. Have a great day, everybody.
Bye-bye.
Bye-bye.